Topic 16, Thermal Properties. Part 1, Thermal Expansion. Temperature and heat. What's the difference? Firstly, temperature is the measure of average kinetic energy in a substance. The greater the rate of vibration or motion, the higher the temperature. Point 2. Heat is the transfer of energy to a substance. It may raise its temperature if the kinetic energy is increased, or change its state if the potential energy is increased. Expansion of solids, liquids, and gases. Liquids expand much more than solids. Gases expand much more than liquids. You might find this one useful. Railway track under the hot sun will buckle because of expansion. Liquid in here will expand when it's heated. Gas in here expands even more when heated. Consequences of thermal expansion. First one is gaps in railway lines. There's a gap there to allow for expansion. And then gaps in concrete slabs. This gap here, that gap there. And then drooping power lines. These power lines are sagging. Applications of thermal expansion. The first example is bimetallic strip. A bimetallic strip is made up of two metal strips, often brass and iron. It's brass, it's iron, which are placed side by side and then riveted together. These are rivets. When it is heated, brass expands more than iron, and so the strip bends with brass on the outside. Here it is. It's before heating, after heating. Applications of thermal expansion. Second example is thermometer. This uses the expansion of a liquid, like mercury, to measure temperatures accurately. When the liquid gets warmer, it expands along the tube. That's mercury there, expanding that way. Applications of thermal expansion. Riveting. A very hot rivet is pushed through two steel plates. These two steel plates. Its end is hammered over. This end hammered over, looking like this other end. When the rivet cools, it pulls the two plates together very tightly. So these two plates get pulled very tightly. And these are a series of rivets. The effect of temperature on the volume of a gas at constant pressure. The volume of a fixed mass of gas is proportional to the absolute temperature at constant pressure. So when the temperature is doubled, the volume will also be doubled. But the pressure is staying constant. This graph illustrates the relationship between volume and temperature of a fixed mass of gas. They are proportional to each other at constant pressure.